So I'm back to the ladder. We now have the engineering problem defined. If we were using a chatbot that I'm sure you all have at some point, we will have to be telling them pretty much all this that we have just discussed. This is the kind of problem, this is the kind of data, we will have to be passing files. It's not a sustainable way, nor the way that we want to show you today. So let's go up the ladder and let's start with Agentic AI. Probably you've heard about this, about AI agents, agentic AI, and you've heard it in different contexts, and so do we. This is used in different scenarios, referring to different things, but consensus, the minimum, let's say the minimum definition is that an AI agent is a system that pairs a language model with three things. First, an environment to act in. Two, a set of tools to act with. And third, a system prompt that defines the job. And then with these three tools, it runs in loops. We have a couple references after the webinar. We're going to show all these slides. We'll show the data, the code, and we wanted to give you some good references to study about this. So this is a very popular talk, quite simple. It goes to the point and touches on these three minimum criteria that we have just defined. There are a couple other references out there. They all go around the same idea. This one is especially fun, and it is so because this YouTube talk is around showing how different models and environments produce different results on the same task. We today in this webinar, we are doing the same. Our challenge is to close that correlation gap with a better physics model or better coefficients. And we're gonna keep the same task and the same prompt with different environments, and we'll see how it evolves. So similar kind of idea, but let's see how an AI agent looks like. There's first a human in the loop that generates a prompt. The model takes the job, and then it generates some action where within the environment that it works in. In this environment, we will have files, data, code, and then after running this action, it will get the feedback, generate another call, and keep going. Obviously, the thing that puts everything together is the tools. The LLM should be able to talk to your data, to run the code, to edit the code. But when tools and environment are combined, you have a loop, a task that can keep going, evolving, trying different things until certain criteria is reached. And this is really easy to start trying already, right now. Agentic AI is really easy on a laptop. At a home level, we have different options like Claude Desktop, Visual Studio Code, plus Claude or whatever other LLM vendor. This is actually what we are going to be using today. You could use Cursor. And just as a silly example of how that will work, let's open Claude Desktop here. And I'm going to do a very simple task. I'm going to say, pick the latest image on the downloads folder and add some sort of animation to it. Let's go back to the presentation. What we've done is the human has set up the call. And if this is an agentic implementation, it'll be able to access the environment, the desktop downloading folder that I was asking for. It should see what it is in there, see what it is about, use some tools to query, to modify, and then when it thinks it's done a good job, it should stop. So I'm gonna send that. This is probably not new. We are not focusing on the actual task. We are focusing right now on the principles. So it's saying, I don't have currently access to your files. Can you grant it? Yes, allow. And now it's doing its thing. So whilst it's gonna do that, it'll take a couple minutes. Let's keep going with our presentation. Let's start talking about the problem. Well, one thing first. I've just said that this is really easy on your laptop at a home level, but the thing that I want to introduce is that it is actually harder to do it at a company level in production. These tools that my Claude Desktop is now accessing live within my laptop, so it's easy. It uses the operating system, the file system, terminal, browser. It is all here. When we are talking about putting this into production at a company level, we will have to access actually internal databases, perform queries, control API systems. There'll have to be authentication and identity barriers. It's a completely different level. So simple context, simple concept, easy to do on your laptop, harder to develop. How did we do it in our task? I'm gonna show you first what I have in Visual Studio. So this is the template of the environment that I created for our AI. As you see, it has access to the code. These, we can just open one of these. This is code as well documented as possible that has the physics of the model, that tells you how to try coefficients, etc. So we have the code, we have the data. This is the kind of data that I was describing earlier. You will see sectors, specific segments, and then the actual data in a compressed format. And finally, we've got the task. Let's see how my prompt looked like. The prompt was, we have a kinematic single track vehicle, the basic model that I was referring to, vehicle model that takes measured steering angle and velocity as inputs and predicts lateral behavior. Baseline is in this code. Its predictions are pre-computed for these, which you can use as a benchmark. And then these are the two metrics that we are looking to improve. The data, the models, everything is defined, and we set up a format that we want the output to be at. You need to put the output there within some predict.py function that I can call. So this is a complete prompt. We are trying to help it. And just like that, I can launch it. I'm not going to do it now because these are tasks that will take 20, 25 minutes, but I can show you the results. Let's go back to Claude and see what it's doing. Okay, it's asking me some options about the animation. We'll leave it working. As a recap, the folder structure that we have just seen fits in the graph model that we were seeing earlier. For the LLM, I'm using Claude, so whatever latest model we have in there. Then I'm inputting the prompt with the task. Then, because we are working in our laptop, our actions are simple and can be done, read, write, bash, Python, we can do all that. Then the environment is the one I just showed you that I created with the data in those formats and the code. So this can go on, try something, get the results, compare, and that's it. At the end, it will decide that it's done and write the model. Something I didn't tell you earlier when I defined the problem is that we've kept some data out of the real data outside of this project so that the agents don't see it. And we are going to use it for validation. So we are going to see how well the models that the agents produce perform against data they haven't seen yet. The best way to assess them, and let's see how they did. Each of those points is the average yaw and lateral position deviation over time that each of the agents that I define in our environment achieved. Basically, I repeated the same thing 10 times to show the deviation. As you know, LLMs are not deterministic. So even the same process with the same environment, the same prompt will get us different results. The loop will work different, and hence we will achieve different models that obtain different results. Still, this is where we were starting from. An ideal correlation, obviously impossible, will be here at 0. Look at the amazing improvement that we've already achieved. All this to say that Agentic, we can see more examples. So the first agent achieved this amount of improvement on the yaw and this amount of improvement of the cross-track error. The second, this one, and I can keep going. And you see there's some variance. Randomly, some do better, some do worse. The ones that do well in one don't necessarily do well in the other. So this is an overall very good process with a huge improvement as we were seeing here, but also a bit of variance. We are not in complete control of the result yet. Again, I think the main takeaway is that if you achieve an agentic implementation, you'll be able to get really good results. Let's go back to our ladder. Again, main takeaway, agentic AI, huge improvement, huge capability versus chatbot. However, what I've just shown locally is a bit harder in production because of the friction points and complexity that I listed earlier. Let's go back just out of curiosity and see what Claude has done. Yeah, allow. Okay, we'll get back later.